The ideas in tonight's homework assignment are not really explained in your textbook, so I thought I'd make a little video explaining what it is I'm having you do once again. Here's some more help, and hopefully fairly detailed help, on question number 5 on this worksheet. Number 5, we have negative 2 times the quantity p plus 3 equals negative 9 minus 2p. The directions say to solve each equation both algebraically and graphically, and then to check each solution that you find algebraically. On number 5, I'm going to solve first algebraically. In order to solve algebraically, I'm going to first distribute negative 2 to both p and 3. When I do that, I get negative 2p plus negative 6 equals negative 9 minus 2p. Now I'm going to add 2p to both sides, since I'd like to get p's on only one side of the equation. Plus 2p plus 2p. These cancel out, and over here, these cancel out. Now I'm left with negative 6 equals negative 9. I have no p's left. There's no variables involved at all. Negative 6 never equals negative 9. So my answer to problem number 5 is that this equation has no solution. That means I can't check my answer algebraically because I haven't arrived at an algebraic solution. However, what I do need to do is solve this equation graphically. The graphic interpretation of this equation is one of the most important pieces to thinking about what it means for an equation to have no solution. So that's my next step. Now I'd like to examine my solution graphically. In order to approach this equation graphically, I first need to rearrange a little bit. My first step in rearranging is that I'd like to consider each side of my equation, the left side and the right side, as a function of x that yields an output y. So I'm going to rewrite y equals negative 2 times x plus 3. I've taken my independent variable p and renamed it x, and I've merely stated that this is an expression which, if I put it in the input, will yield an output. On the other side, I'm going to say y equals negative 9 minus 2 times x. I've renamed my independent variable p as x, and I said if I input values for x, I'll get an output y. Now I'd like both of these equations to be in mx plus b form for graphing. So I'm going to distribute over here in my left side equation, which gives me y equals negative 2x minus 6. Then on the right side, I'd like to rearrange so that the mx comes before the b. So I'm going to write it as y equals negative 2x minus 9. Now I have both equations in their slope-intercept form and ready to graph. I'm going to start by graphing my left side. The left side, I've got the line y equals negative 2x minus 6 to represent this idea on the left side. Here's a line that's got a y-intercept at 0, negative 6, and then it has a slope of negative 2. A slope of negative 2 means this line goes down 2 over 1, down 2, over 1, etc. I can also extend the line back 1 and up 2. So now I'm going to draw the straight line with a slope of negative 2 and a y-intercept at negative 6. There it is. Next, I'd like to examine my red line. The red line has a y-intercept at negative 9. I'm going to put a y-intercept here at negative 9. 0, negative 9. It also has a slope of negative 2. Again, I can think about that slope as going down 2 over 1. But since I don't have enough space there, I'm going to go back 1, up 2. Then I'm going to draw the straight line with a slope of negative 2 and a y-intercept of negative 9. There's my line. Of course, I'll label each line. Here's the line y equals negative 2x minus 9. And here's the line y equals negative 2x minus 6. Also, I should label my slope triangle on each. This slope triangle goes down 2 over 1. And this slope triangle also goes down 2 over 1. Okay, this visual representation of my original equation is what I need to be thinking about to explain why these two lines never cross. To explain why these two sides of the equation have no solution. The fact that I've graphed two parallel lines which will never intersect is the visual representation of an equation that has no solution. That picture and the work on that equation is what you should have shown for number 5.